in Python, capital letters and small letters, sorry, capital letter and small letter, they are different. Python the capital letter ka small letter ka kene ka. So if I write done with a capital D, the loop will still continue. It will not break. The loop will break only when we write done with a small d. So if I write done with a small d, then the loop will break. Then the loop will break. See, loop say line equal to done or break or now we are outside the while loop. Outside the while loop, nina magi body is amata shivawa amata execute toroy. Then the next statement will be executed, which is print done. Print done. This is how a while loop works, and this is how we can input break. Break se marak option ba. Sigi condition true whatever dum thamaga marak break option laga. Si kram kind of break to ba if condition nama satisfied or gadi break to hai ba. Duna sigi cell all current output clear. So clear to gaya. Sigi output me clear to gaya. Duna the loop condition is true. The loop condition is always true. The loop condition is always true. The loop condition is true, which is always true. So the loop runs until it hits the break statement. Each time true, it prompts the user with an angle bracket. If the user types done, the break statement executes. The break statement exits the loop. Otherwise, the program echoes whatever the user types and goes back to the top of the loop. Aduna done have and enter the program echoes whatever the user types and goes back to the top of the loop, and the loop is executed indefinitely until you enter the word done. This way of writing while loops is common because you can check the condition anywhere in the loop and not just at the top. And you can express the stop condition affirmatively. Stop when this particular condition is satisfied. Stop when the given word is equal to done. So affirmative when I stop rather than negatively. Si condition ji yad kan to have do not taba si condition ji yad kan to have chai koi gi blast off study si condition ji yad kan to have neba yai gai to yad kan to have neba sidana si condition ji theng ga to have neba aduna si gi jina negatively stop to neba ko si condition ji yad kan da lepu haiba hojiki jina Sigi condition is yaraga di lepu haiba. So affirmatively stop over mamang viduna negatively stop over there. Example am khanaraje. Siam interesting example ni. This example is very interesting. Square root. How do you find the square root of a given number? Okay, ankada given number amagi square root hopagi method amalai. Aduna taba yam nova computer sizinaraga hotpa yaba method amalayeba Newton's method aduna loops are often used in programs that compute numerical results by starting with an approximate answer and iteratively heading sagi to hanjan repeatedly loop to iteration to hai ko just hai ki dai iteration right again Tibu khangjalaktre iteration kai sakrai tipangdre repetition ji bo khona iteration kawi na sai ai ji budo okay the last is example to last so loops are often used in programs that compute numerical results by starting with an approximate answer and iteratively improving it. Loop improve to. For example, one way of computing square root is Newton's method. Suppose that you want to know the square root of a number a. A have a number square root to pame. If you start with almost any estimate x, you can compute a better estimate than x with the following formula. When a have a number amagi square root I want to find the square root of a number a. Say class 8 9 square root one abagi division method amal lay adu tor follows jai adu natabida computer da hapsalaga loop sisinaraga hanjana iteration to holaga more and more accurate answer phangnabagi provision amju layeba adudi kaino Newton's method kaweba. Newton's method chana kari hai a have a number pyramid. You are given a number a and you are asked to find the square root of a. First, you divide the number a by x. X have a estimate. I'll take any number x as an estimate. Suppose you want to find the square root of 4. 4 is square root. Follow haragadi is 4 square root 2 ni has a 4 square root say follow high target I can start with any number say 3000 3000 3 is the estimate. Then what do? We divide the given number 4 by 3 let it go 4 by 3 and then 4 by 3 is what it is 1.33. Then we take the average of that 1.33 with the estimate 3. Aduna 3 ga 1.33 ga anisigi average laura and you will get a new estimate y which is closer to the actual answer 2. Aduna sigi process se hanjan tauraga say y equal to x plus a by x by 2 have said sigi process se hanjan tauraga I more and more accurate value of square root hanganeba. More and more accurate estimate of the square root hanganeba. Say example yenga seba. Okay, let us look at the example. So the given number is 4. You are asked to calculate the square root of 4. You start with an estimate. The estimate is you take let the approximate square root be 3. See how we have gone. Starting with the estimate I don't know. Starting with the estimate 3. Then you perform this operation. You take the average of the given number, the estimate x and a by x. So average divided by 2 haramina. Then you print the value of y and y becomes your new estimate. So I run to sigi CLG run to ko. 2.166666 So 4 is square root follow haragadi ay kaide hore 3 have a estimate am loksale adudagi 4 divided by 3 tore adi 3 duga anisigi average lore ay new estimate ama phange 2.166666. Now this is my new estimate. Sigi new estimate se amuk sisinare sigi new estimate se amuk x ohele ko aduna sagdingo hajikidura aina ahanba 3 lobuni ko aduga new estimate ama phange 2.1666. The result the new estimate is closer to the correct answer 2. Sum naksla kadoine ko correct answer to that. If we repeat the process with the new estimate, it gets even closer. So new estimate y is and x assign tore now y is my new estimate and then I calculate the average again. Already I mathang khara phaba estimate ama phanganeba. So I 2.166666 na estimate orega I adu x hapsale adu I new estimate che amu hole. Let me calculate this. Let me run this cell. Now I get a newer estimate 2.0064. Sina hanagi 2.116 ki kena accurate oiko because this is closer to the real value 2. Now I use this as a new estimate. Si amu new estimate oina amu sizinare. Adridi ngasai ki sigi program je amu run tore. New estimate oina amu sizinare. Then I take the average of this new estimate and a by x. So I get another new estimate 2.0001024. Nakshala adra. So now I use this as my new estimate, and then I proceed in the same fashion as the above. So I know close. So I get nearer and nearer and nearer to the correct answer. New estimate y equals x plus a by x by 2. Now I get closer and closer. Ultimately, I get 2.0. So this method is called Newton's method. Aduna ai khana rough estimate amadagi hen accurate estimate sum naksalaga yam naksalakane ba ai real value to yam naksalakane more and more accurate answer phangkane Newton's method chiko ko aduna in general we don't know ahead of time how many steps it takes to get to the right answer. Aduna aina sigi process se karak aina ahanba 3 have a rough estimate ama lopsalaga aina hojiki average lowgi process to karak hanjan torganda accurate value phangni habasi ai hana khangdeba mangarak torga phangadra 20 times toro phangadra 1000 times toro phangadra ai hana khangdeba ko aduna in general we do not know ahead of time how many steps it takes to get to the right answer, but we know when we get there because the estimate stops changing. I right answer to la kan di ai estimate change the so I said quite last estimate to 2.0 phange ko c 2.0 se amuk ai x tam hapsale new estimate amuk kohele aduga si amuk evaluate tawre. Let me run this again. Run 2.0 dum tare. So my estimate no longer changes. So this and this no longer changes. Ai estimate se change tawdragadi. So when the estimate stops changing, we are sure that we have got the correct answer. Ai estimate se makata na change tawdragadi, we are sure that we get the correct answer. Aduna so sagi estimate 2.0 sigi matangda aina amuk better estimate ama amuk thina kona bada same 2.0 dum tare. That means y is equal to x. My new estimate is equal to the old estimate. Magi head mamang la yiba estimate to ga new estimate to ga manare. Then we can stop. Here is a loop. Aduna sigi estimate last estimate siga last but one estimate siga manaragadi a correct answer to tare. Then we can stop. Adu lepe yareba. I program Z, I have run it repeatedly once, twice, third, fourth, fifth. Sigi program Z, I mangar hanjan repeatedly run taweba. Smaina hanjan repeatedly run tawase. We can replace this repeated execution by a simple loop. Loop ama seasonal ayam line program ama khatang iraga. Achieve to hanba. So we can. Here is a loop that starts with an initial estimate x and improves it until it stops changing. So loop sizinaraga hajiki program do ai hanjan mangarak tarulak run tawudu loop sizinaraga hanjan run masam run to hanba yayaba. So we start with the number a equals 4. Then the first estimate x equals 3. While true, ideally true, the while loop will be executed. It will be broken by using a break step. Break command sinaga maji break to budiani while loop se run to lerani print x, print the initial estimate, then you calculate the average value. If you run this loop, you perform this looping or you perform this iteration n number of times, any number of times until you get y equal to x. See condition is satisfied. Group say you run this statements repeatedly. Have never gone. Quite first print x 3 is print next 3 ga 4 by 3 ga average lorani. Then we assign that number to y. Now y is the new estimate. Check check now new value of y duga masagi x equal to 3 duga manaribra check manaragadi break initially the x equals 3 ga y gadi manade. Therefore we move to the next statement adudi kedore y ji amuk x ta hapsal le adi kaino ai sida phangriba new estimate che ko x am hapsal le ko so this becomes my new estimate amu new estimate se print tawre adudi new estimate ama mu hole and so on new estimate se sigi average lor hanjan better and better and better estimates sum hole until what until the estimate no longer changes breakdown never so let us run this program so x equals 3 this was the first estimate this was the second estimate third estimate fourth estimate fifth estimate sixth estimate and at the sixth estimate we get the correct answer which is 2.0 which is the square root of 4 aduna ai isam chamba while loop ama seasonarga ai sidanga sagi mangarak taruklak run tawuse ai while loop sida doinamak to hambi agre so you perform this looping until the last two estimates are equal if the last two estimates are equal you break the loop you come out of the loop so this is the result aduna aina ai sigi program je sigi je hanjan yam sangna idu sarukudi I can write a very small program using a while loop next for most values of the given number a this works fine but in general it is dangerous to test float equality that you can ask the y equals x whenever these two are floating point numbers and floating point numbers the equality check over there this is very risky this is a very risky habit floating point values are only approximately right most rational numbers like 1 by 3 and irrational numbers like square root of 2 cannot be represented exactly with a floating point number. Floating point number only approximate value never exact value p most of the time. Approximate value p number approximate of a number ani manabra na check this is very risky because floating point values are only approximately right exactly right or can the check to be in integer but floating point study approximately right this is very risky y is equal to x and check to very risky then what do we do in such a case rather than checking whether x and I are exactly equal it is safer to use the built-in function abs the absolute to compute the absolute value or magnitude of the difference between them. Do it target the floating point when we are dealing with floating point number. It is more it is better to check how the last two values differ. Approximation see quite last approximation 2.000026214 2.0 and is difference cam difference check if the difference is very small if the difference between these two numbers is very small it means we are very close to the correct answer see an easy difference differences is checked on see difference positive number negative number and the negative number is always less than 0 see positive number negative number case satisfied absolute value and we compute the absolute value or the magnitude of the difference between the last two approximations. Last two approximations last two estimates see an easy difference absolute value the same program but instead of equality checking and equality we are checking that the difference between the last two result is much it is less than a small quantity aduna si umune ko aina sida policy a equals 2 hare ai 2 gi square root hotu neba I want to calculate the square root of 2. I want to calculate the square root of 2. I start with an initial estimate 3. 2 square root t, it is approximately 1.414. So let me start with any number. So the estimate is 3. 3 is in there. Then I define a new number epsilon. And epsilon equals to 0.0000 0 yamale minus 1 0.01 0.01 epsilon is 1%. 0.01 1 divided by 100. 1 divided by 100. While true, perform this estimation. So all estimate 3 is the new estimate y among toro. Y is x all estimates new estimates y the difference is the difference larger than or less than 0.01. As long as the difference between the last two estimates is larger than 0.1, you continue with this loop. Last estimate ani dugi marakta x ka y gi marakta the difference to 0.01 dagi you continue this loop. The moment the difference between y and x becomes less than the value of epsilon, which is 0.01, you break the loop. I want my answer to be correct only up to the second decimal place. Second decimal place, I answer to Sumagadi, a yare have never got. So let us run this. Second decimal place, 1.414. 1.46, 1.41. Second decimal place, and if I want more and more accurate answers, then I can add more and more zeros here. 1.001, 1.0001. If I use the value of epsilon like this, fourth decimal place. Now let me run this again. Now this is correct up to the fourth decimal place. If I want more and more accurate answer, I can increase the number of zeros. 0.000000. Then I will get more and more accurate answers. More and more accurate answers. So this will be sufficient, I think. Aduna floating point number. When we are dealing with floating point number, this method is preferable. If the absolute value of the difference between the last two estimates, if the difference between the absolute value, if the absolute value of the difference between the last two estimates is less than epsilon, where epsilon is a small quantity, this. If the difference between these two number, magi absolute value do sigi numbers I will accept the answer as a good answer. So chapchana y x ka manadribo togo floating point number is one man. This might never stop. Accuracy is 10 decimal place accurate or yare epsilon j 10 decimal place epsilon is 1 divided by 10 to the power 10. 0.000 mapan thamaga 1 thamal. So that means I want my accuracy up to the 10 decimal place. To break a while loop, we'll often use a condition like this. That is, if the absolute value of the difference between x and y is less than my epsilon, then break the loop. So this is the value which is acceptable up to this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. See what acceptable over there. Next, while loop key another application. I want to calculate, or I want to write a table of conversion from Celsius to Fahrenheit scale. Celsius scale dagi Fahrenheit scale the convert table lama ipameba. First, I'll write Celsius equals minus 20. This is the starting point. This is the starting point. Then next the DC. Change in Celsius. Minus 20 degree horani. A 5 step, 5 increase. So start from minus 20. Then you add plus 5. That is minus 15. Then minus 10. Minus 5. 0. So this is the increment of C in loop. While C is less than or equal to 40, while C is less than or equal to 40, the Fahrenheit reading is 9/5 into C plus 32. Print the value of C and F separated by a tab. Separated by a tab space. Next step to C to the originally C equal to minus 20 to the you increase the value of C by steps of plus 5. C plus 5. C increase our. So initially C was minus 20. Minus 20 is less than 40. Therefore, this formula converts the value of C to F. Then the value of C and F is printed, separated by a tab space. And the next statement, the value of C is increased by 5. And then this condition is again tested. Second condition is test our minus 20 to 5 minus 15. Minus 15 is still less than 40. So these statements are again, this F is again calculated and the values of C and F are again printed. Then the value of C is increased by 5 again. C is in a minus 20 with the F C print over. C is in a minus 15 with the F C print over. C is in a minus 10 with the F print over. You continue this process until C is equal to 40. Continue to until C equal to 40. Continue to print over. After that, stop. So let me run this. See print in a line. See quite last print statement. So let me run this cell. This is the output. So starting from C equals minus 20, we get the corresponding temperature in Fahrenheit. Minus 15 corresponding temperature, minus 10 corresponding temperature in Fahrenheit. So the first column is the column in Celsius. The second column is the column in Fahrenheit. So starting from minus 20, we go until C equal to 40. C equal to 40 volts a level. At C equal to 40, the Fahrenheit temperature is 104.0. By changing this step, so DC is increment in C is 5, there is a 2, 2, 2, when gets 10, 10, 10, when gets so let me change it to 10. 10, 10 step to increase the let me run this again. 20 minus 10, 0, 10, 10, 10 step to quite last print statement, print quite last table print over. This is not important. This is not important. It simply prints this hyphens. Print over whatever. It simply prints a string of hyphens. Now, this last print statement is optional. So this is an explanation of the above program. As you explain proper explanation. Okay, now let us move to the next example. Program sum of 1 to 100. 1 begin 100 for tension now have 1 begin 100 for tension now have say 1 plus 2 plus 3 plus 4 plus 100 for I can use it using a very simple while loop. While loop taruga 1 2 3 4 5 6. Using 6 statements, I can calculate the sum of any number. 1 1000 1 lakh. Starting from 1 to any number, I can calculate the sum by using only 6 lines of statements. Power is sum initialize sum equal to 0. This is called initialization. The I equal to 1. This is called initialization of the variable. Variable test I. So first, the test variable I is initialized. Sum final answer of sum is also initialized. So when I have sum equal to 0, I equal to 1. While I is less than or equal to 100 and say like give us sum to the I tins law. Aduga you assign that final answer on the right hand side, you sum on the left hand side. Then in the next step you increase I by 1 because I want to find a sum of 1 2 3 4 5 6 7. I don't know steps 1 1 1 so I equals I plus 1. Aduna you continue this loop until I is equal to 100. Aduna I is 1 or any. So let us start with I equals 1. I equals 1. This is true. This condition is true. Therefore, sum equal to sum initial value is 0. 0 plus I is 1. 0 plus 1 is 1. Next step 1 plus 1 2 I equals 2. Now in the next step I is 2 2 is less than equal to 100, which is true. Therefore, this is again calculated. So समझे से क्या होगा 1 होगा. So समझे से क्या होगा 1 होगा 1 plus 2 equals 3 तारे 3 जो वहाँ चले समझे sign तो चले. Then we increase I by 1, so I becomes 3. अदुना स्वाइना 1 अमुक division by 2 अमुक division by 3 अमुक division by 4 अमुक division by 5 अमुक division by so in this line we are adding 1 2 3 4 5 6 and so on until I is equal to 100. Aduna 1 begin 100 folks say sum tanjan and tinjalo have never. 100 the moment I increases to 101, the loop is no longer executed. I is 101 over this condition is false and the statement these two statements are no longer executed. So quite last like give some value the print or ane. So 1 then 100 folk talk doing that 1 then 10 because we know the answer of sum from 1 to 10. 1 then 10 book the answer is 55 never. So let us check whether it gives us the correct answer 55. Let us run this. Answer is 55. So make okay, this is correct. Let us check it to 25. Sorry, 20. 20 bhautana 225 taba. Sorry, 210 taba.
210.
So now we can check this for 100. 1 to 100. 1 then 100 for kya tani? N into n plus 1 by 2 hydra. Kya tani?
5050.
5050. So this is a program. This is a small program which can be used to find the sum of the first 100 numbers or the first 1,000 numbers or the first lakh numbers, or we can start from I equal to 1 I equal to 11 aduna I 1 to 100 have any I equal to 1 starting number duni 100 na last number duni. So by changing these two values I can find the sum of any numbers from some starting value to some final value. Change the way I have. Aduna horen yum the halaga sigi semdo over 50 the 100 folks sum to over. Find a sum of 50 to 100. You simply change I to 50 and this is 100. So 50 then 90 to now this I will be 50 and this boolean test boolean expressions in a 90 or any. So we have less than 1 minute left.